I think the fundamental issue with humanoids is that it just lacks creativity. If you were redesigning something from scratch, why would you keep it to 2 arms and not 6 arms? The main directive I've given to my sales team is like, invent a product that you would have to be stupid to say no to. The result of that is we have now a 97% renewal rate, as close to zero churn as you can get in a startup. People are trying to pattern match what happened in LLMs onto the world of robotics. And I think it's very seductive, but it's a mistake. And there's this idea or this narrative that once the robot works, then adoption is going to happen instantaneously. Yep. My observation of this industry for the last 10 years has been the opposite. Getting the robot to work is the easy part.
What has this past year taught you about building a high margin hardware business?
So there's a couple of foundational principles. One of them is
Hey climbers, welcome back to Climb by VSC. I'm Jay Kapoor, General Partner of VSC Ventures, and I'll be your host today. I am so thrilled to have on the show Saman Farid, who is the founder and CEO of Formic, the largest independent robot fleet in the United States, with over 500,000 production hours and more than 100 factories where they have robots that they own and operate. Before starting Formic, he spent a decade as a robotics investor at Baidu, deploying over $650 million into 40+ robotics companies, until he realized that the entire industry was solving the problem wrong. So we're going to talk about his time in China. We're going to talk about his time as an investor. But more importantly, we're going to hear his hot takes on robotics, automation, deployment, and yes, humanoids. Saman, thank you so much for joining me on the show.
Thanks so much for having me. I'm excited to be here. This is a lot of fun.
Let's jump into where I was setting up a little bit. You grew up in Beijing. You watched China go from dirt roads and donkeys carrying bricks to the manufacturing superpower of the world. And then you invested $650 million across these 40 companies. And after all that, you decided the biggest problem in robotics wasn't actually the robots. So tell me about what you saw and what was that moment where you realized, hey, the real problem to solve is somewhere else.
My parents moved to China when I was 6 years old, and we were the only kind of non-Chinese people in my school and in the whole area that we lived in, and people would stop us on the street and kind of be surprised that there was a foreigner around. But I feel extremely thankful that I got to experience China going through this like massive industrialization process where incrementally you could see how every aspect of people's lives improved as a result of this strengthening industrial base. People's daily lives are highly dependent on the ability of their society to kind of produce the things that they use and need on a daily basis. And during my childhood, I got to see a lot of that. And then later on, as an entrepreneur, I got to build factories in China, and I got to work with a lot of manufacturing businesses and technology companies in China. And I got to see the rate at which the expansion and adoption of new technologies was able to really massively push society forward. But the thing that I kept realizing over time is that there's this kind of common cliche in Silicon Valley: the future is here, but not yet evenly distributed. And I think that's extremely true in robotics today, where if you go to kind of any robotics lab, or you go on YouTube, frankly, you can see robots doing backflips, you can see robots doing all kinds of cool tricks. But if you go to any factory, if you go to any construction site, if you go to any farm, there are no robots to be seen, right? And for me, like, that was really the big gap in my mind, which was, on the one hand, like Silicon Valley and me as an investor, we're investing in lots of new types of robotics companies, a lot of new capabilities, robots doing new tricks every single day. But there's this massive chasm when it came to adoption into the real world. And what I've seen in technology is really this diffusion of technology is what really gets me excited. Like the incremental new trick is nice, but getting it into people's lives where it's actually helping people live a better life and make better things, that's what really matters at the end of the day.
You invested in 40 different companies. You saw this industry changing in robotics over these years. And right now you have an entire industry where 95% of the money is going into humanoids or foundation models with very little implementation. What is the industry getting wrong? And how are you seeing it differently at Formic?
People are trying to pattern match what happened in LLMs onto the world of robotics. And I think it's very seductive, but it's a mistake, right? In the world of LLMs, essentially what happened is these kind of LLMs weren't very good until finally ChatGPT came out and people realized this is actually working. And then you had this massive takeoff of adoption. There was real revenue behind all of those businesses. Obviously they're spending a lot of money in training the next version of the model and infrastructure, et cetera. But all of it is backed up by the fact that there are real world users on most LLMs today. Switching to robotics for a second, like people are saying, when is the ChatGPT moment for robotics going to be? This is what I hear a lot from investors. And I think it fundamentally misunderstands the dynamics of the industry, and it's just completely different from LLMs. There's this idea or this narrative that once the robot works, then adoption is going to happen instantaneously. And my observation of this industry for the last 10 years has been the opposite, which is actually getting the robot to work is the easy part. You can go to any lab, you can go to any, pitch event in the Bay Area, and you'll see tens of startups or, companies who have robots that do different things. Oh, I can pick strawberries, I can fold laundry, I can, till the soil, I can, look for weeds, whatever, right? Like any kind of possible use case you can imagine, somebody's built a robot that can kind of do it pretty well. Adoption has actually been the hard part.
Yeah.
And so while like we're enthusiastic that these robotics foundation models will get better, the reality is they're solving a part of the problem that is actually marginal to the overall impact. And I can say this as Formic because we've now deployed hundreds of robots in hundreds of factories. We own and operate all of these robots. The time and energy it takes us to program the robots is less than 5% of our deployment cost. And so what follows is, okay, let's just say magically tomorrow these robotics foundation models were perfect and worked amazingly well every time. The net impact is you've reduced my programming time from 5% to maybe 1%, because I still have to pay them, right? So now it's 1%. Like it's actually kind of inconsequential for my business, right? As I'm deploying lots and lots of robots. And I'll venture to say we are probably the largest scale robot fleet in America today that's kind of owning and operating robots in a variety of these different kinds of use cases. So I think our experience here is pretty relevant. So all that to say, like, again, I'm enthusiastic by these robotics foundation models that are getting better, but I don't think there's going to be a single ChatGPT moment on the model side.
Well, and that's the interesting part, right? Is the ChatGPT moment happen when we realize that you throw more compute at the problem, you can kind of brute force train these models, and you will see model improvement, and you can plot that out. And that's what capital loves. Capital loves being able to say, okay, great, $1 in, 9 months later, $12 out. Hell yeah, man, I'll lever up and I'll invest in that all day. And I think the point that you're making, which is really apt, is we don't have that equation figured out in robotics yet. Hardware for a long time, I think a lot of software investors don't appreciate just the supply chains involved in like getting the hardware together. Then you add on top of it the inference that you need to actually train these robotic models, and the scale of the capital that's going into it doesn't line up with the capital today. Is it just that people are betting that this is where the world is going, and so therefore, you just got to be directionally right, and the time scale will figure itself out, or is it something else? Like I mean, my to give you my take on it, I think like Opus 4.6 was such a interesting moment for investors. We've been doing robotics 2-3 years out of our portfolio. The number of co-investors that have come to me in the last 3 months and said, hey, what's going on with this company? Because everything in my software world, my SaaS world, my vertical AI world over here feels like it's indefensible. But it seems like this physical AI thing is something real. And so I do wonder if it's capital chasing narratives or if it's capital just going, well, directionally we know robots are going to be there. Maybe the time scale will match up too.
I'm a strong believer in the fact that I think the physical applications of AI are going to they're going to dwarf the financial impact and returns of pure digital AI. Physical applications of AI. I mean, the way to think about it is if you go to any city in America, there are people in that city that work in construction, agriculture, manufacturing, healthcare.
The dirty jobs.
Things like that. Yeah. There's very few people in Minnesota that work in software, for example, right? Or if you go to Indiana or Iowa, or let alone if you go to other countries. And so just the overall size of the market and the opportunity and the demand for products from the physical world is just so much higher. So being able to kind of contribute and supporting that is hugely impactful. But to your point, the challenges are different in scaling a software business versus a hardware business. I think going back to this issue of pattern matching, what a lot of people are doing is pattern matching like these kind of AI software companies to robotics companies. The thing that people miss in the AI software companies, or at least the foundation model companies, is that really what's valuable about those businesses is not the model itself. What's valuable about those businesses is the fact that they have a flywheel where they have a lot of users that are using that model, and from that they're generating information about what kinds of responses are good, what kinds of responses are bad, what are the kinds of engagements that people are having, and they're using all of that data that they're generating to train better models.
Yep.
And that loop really is, comes down to two things. One is the software capability to actually do it. The second big one is distribution, right? Like you have to have lots and lots of distribution. I think in robotics companies today, people are really focused on like the model capabilities themselves. They're not really focused on the distribution side of it. And I think the reality is in robotics, the data problem is much, much bigger than in LLM training, for example, where you already have troves of data that you can mine from the internet. In robotics data, there's just such a shortage of high quality, real world production data. So I think my bets in this space are mostly going to be around what can get rapid, large volume of distribution and what can translate that distribution into a meaningful data advantage. That's really how you get the flywheel spinning in robotics intelligence.
Well, let's stay with that dissonance of what software investors think versus actually happens when you're deploying. You've said that the robot is only 10% of the problem. The other 90% is error handling, maintenance, programming, change management. Give me an example from a deployment that would make a software investor's head spin. What's the most absurd kind of failure case you've seen when the plan actually meets first contact with the enemy?
Oh man, I have so many of these, right? I mean, I think that I'll give two because they're a little different. One is like just fundamental physics, right? Robots are designed with a certain capability set. So you can say this arm, this set of motors and actuators and controllers and grippers can pick up something up to, let's say, 30 pounds, and it can move at this maximum speed. That's like fundamental physics, right? That those constraints don't go away if your intelligence gets better. And so when you're on whether you're doing a production line, whether you're using robots for any other task, there's a range of capabilities that robot can do, and no amount of AI is going to change that. And so what happens is, like in production environments, for example, let's say a factory is running a certain SKU, they might run that SKU kind of all day, every day. And then on Sundays, though, they run some different SKU that happens to be heavier or bigger or faster. And now all of a sudden this robot can't keep up. And so I think that there's a big scoping problem on the robotic side, which is you have to kind of predetermine what your range of capabilities need to be to get the maximum envelope of tasks that you can solve. So that's one. The other really interesting thing is there are just a bunch, you asked for absurd, so I'll share an absurd example, which is early in our life, we had this problem where we would scope out a solution. We say, okay, we need this type of robot, and it needs to go here, and it needs to have this gripper and that set of capabilities in order to accomplish this task. And everybody would be aligned. It looks great. The factory that we were working with bought into the plan. And then on the day of deployment, we show up with the truck, we roll the robot off the truck, and we're kind of trying to roll it to the room where it's supposed to do the work. And it turns out that the door in between is too narrow to fit the robot through. And, like these are just, so, we added it to the checklist and we're like, next time we sell something, let's make sure to check all the doors, right? But there's 100 little things like that, right? Which is like, is there a column in the way? Is there a beam? Is there direct sunlight that's going to wash out the camera view? There's, is the bag porous? Is the bag that you're picking up porous, or is it hard? Can you pick it up with suction, or can you pick it up with grippers? There's like maybe 500 pieces of information you need to collect before you can actually design, scope, and deploy a robot successfully.
Yeah.
And again, like the robot being smarter doesn't magically absolve you of doing all that work.
Yeah.
And I think that's the part where investors are not going to like what they encounter, because they're investing in these foundation model companies saying intelligence is all that matters. Once the robot's smarter, then we're all set. But what's going to happen is, in practice, when they're starting to deploy robots, they're going to encounter all of these different issues.
Where does this show up in the cost structure, though? Because you mentioned that only about 5% of your cost structure is the model training cost of the robot, the intelligence piece, right?
Yeah.
All these other aspects of deployment, they've got to show up somewhere. I mean, you grew deployments 5x year on year. You figured out how to bring down the cost per deployment. You sped up the amount of time, or I guess you shortened the amount of time it takes to go from contact to deployment. That's got to show up somewhere in the cost, right? So what has this past year taught you about building a high margin hardware business?
So there's a couple of foundational principles, and none of this is like breakthrough rocket science, right? But one of them is remove customization as much as possible and try to make it close to zero. And number two is build modular, standardized systems that don't require customization for different tasks. So like you can think of like Lego blocks, right? That you can mix and match different components and deploy it for a task. I think those are the two principles that we've kind of applied. And so to your point, I think in traditional robotics, about 60% of the cost of the deployment is in the manual hardware configuration and integration work. Right? It's like, how do I make it connect to this conveyor? How do I make it connect to their ERP system? How do I bolt it to the ground? What about all the safety infrastructure? There's like 100 questions, and then every time people do a custom design for that task. Obviously, that's not feasible when you're trying to build a rapidly scaling business. And so what we've done at Formic is we basically compressed all of that work into software. And so we said, okay, we built this tool called Formic Cortex, which automatically analyzes all the requirements of the task, selects the standard modules that we need, validates them in simulation, and then once we deploy, basically uses cameras in lieu of basically all other sensors so that the system can be fully self-sufficient. So instead of having to integrate with the conveyor or integrate with these kind of other machinery that is upstream or downstream of our robots, just like what a human does, they can observe what's coming and they can integrate.
So no PLC integration with their existing conveyor belt or anything like that. Exactly. It's just all vision based.
That's right.
Got it. So that allows you to speed up and say, look, as long as our vision models are catching this within the right error rate, I don't have to worry about what's already in your facility. I just show up and I'm kind of ready to go out of the box.
Yeah.
Yeah, interesting. This is typically work that is done by system integrators. And you've got some thoughts on systems integrators. Where do they show up and actually need to be a part of the ecosystem? And where are they making everybody's life harder?
System integrators will be useful in this kind of new world order for sure. But there's a couple of big issues with system integrators. The biggest issue is that there's this incentive misalignment that is common in really any consulting heavy business, which is they're incented to do complex custom projects because they're billing for engineering services and engineering hours. So the more complex and more custom a project is, the more engineering hours they have to bill for. And so they actually have a disincentive towards adopting modern technology to simplify and automate their work. So that, I think, not just the situation in robotics, but the problem is in robotics, historically, the vast majority of sales have been done by system integrators. That's right. And so they control the market demand and they control the means by which you're delivering, which is why a lot of these robotics companies who have been trying to sell to integrators or through integrators have basically all failed.
Yep.
And so what you need is to bypass the set of tasks that an integrator traditionally does. So this is where what we were talking about earlier around Formic Cortex comes in, is we basically abstract away all of the decisions that an integrator traditionally makes, and we automate that work. I think where an integrator will come in useful in the longer run is when you need to do very, very complex integrations between different systems. And so if you have 100 different kinds of robots that are all interconnected and they all need some way to talk to each other, to a standardized database or to another facility or to your ERP, in those situations, I think integrators' work is much more valuable. But even that, Claude Code honestly is replacing a good chunk of what they traditionally would have done. And so I do think integrators need to figure out what their model is going to be in the future.
One of the reasons I was super excited to talk to you about is in robotics, in AI generally, we're seeing business models change. And the last couple of years, the thing that I think got some investors excited about robotics was robotics as a service. Oh, it looks like a model we understand and know how to pile cash into. It looks like SaaS, recurring revenue. We can price against it. We can fundraise against it. You're doing something unique. You're doing utilization-based. You're doing success-based. We're starting to see the agentic token world go in this direction. You've already been living in this future a little bit. Help me understand why this is a better business model for you as a venture-backed company to focus on utilization and outcome-based pricing versus being able to just say, flat fee, cost plus, something different.
I'll push back a little bit on the question because it doesn't matter what's better for me as a venture-backed company. It matters what's better for my customer, right? I think the fundamental question is, what is more likely to drive a better outcome for the end user? And my firm belief here is having some amount of skin in the game in terms of delivering on your production outputs and your production goal and having an aligned incentive is going to ripple effect into every decision that you make across the business to ensure that you can do that. And I think this is, of course, the downstream effect is that if you do that well, I think it makes for a fantastic business. But the fundamental question is, if I was a customer, what would I want?
Sure.
Right? Would I want somebody to sell me a few $100,000 of CapEx and then have no responsibility after the fact? Or would I want somebody whose feet I can hold to the fire on a performance basis? And obviously, I think the answer is the second, right? So I think as we wanted, a big goal of Formic is to drive adoption of robotics across a much, much wider scale. Now, I think there's the kind of second layer, which is, okay, if you agree that robot as a service is better for delivering performance outcomes, then how do you actually do it as a business and survive? That's actually also a very, very hard question. And fundamentally, there are examples of this that you can look to and learn from. So one example, for example, is Caterpillar has this idea of power by the hour, where you pay for performance of your equipment. Or Rolls-Royce does this with their engines, or to a large degree, AWS and companies like that allow you to pay for utilization. And so how do they do it? Right? A lot of it comes down to having very good predictive models for what the likelihood of future utilization of an asset is going to be, and to think of these assets as revenue-generating assets. And what we've done over the course, of the last few years that we've been in business is we've built a very good model that predicts what the expected utilization of an asset is going to be in a certain environment with a certain credit quality customer, with a certain use case based on a certain set of technical constraints. And when we can predict that well, then we can actually figure out what the kind of expected cash flows are going to be from a specific robot. It turns out robots are a very good asset class, right? So we're generating roughly 65% net asset IRRs on these robots. And us believing it is one thing. What really matters is ultimately, do the capital sources believe it? And we've now actually, late last year, did our first securitization deal where we basically put together a pool of these assets and had asset equity and debt investors come in and basically buy the securitization of this facility. And they underwrote it with their own models. They said, okay, look, I see this certain renewal rate. I see this expected utilization. I expect this certain amount of revenue per robot. And if I assume that, let's just say 10 robots pay me for 1 year and 9 robots pay me for 2 years and 8 robots pay me for 3 years, then I can basically model against that set of expected future cash flows to fund.
How soon do you think a founder can do this? Asking as a pre-seed and seed investor to say, look, there is a certain safety in, flat annual fee or monthly fee where you can say, look, we can plan against this, we can hire against this, we can model against this. to create a predictive model at the scale that you have, you need enough data points to go, we're not going to have, super lean months and super heavy months, and we can smooth out that utilization to, in the aggregate, look like monthly recurring revenue. At what point do you feel like you have the confidence to go do that maybe, somebody doing their first or second deployment wouldn't have?
The easy answer is like you need probably a few hundred data points over a couple of years, right, for other people to be willing to buy your underwriting model. That being said, there's scaffolding along the way that allows you to access different kinds of non-recourse capital on the way to being able to do a full securitization. That kind of scaffolding essentially comes from different things. One example is what's called a forward flow program, or initially a lot of companies take on recourse debt against the business, which is a dangerous thing to do. But there are basically there are intermediate steps that you can do to kind of try to prove out and build out some of these data points that don't require you to put lots and lots of equity dollars into hardware. But I will say it is hard to do, and I think that there are a lot of economies of scale that come from having done it for one pool of robots. Because now that we've done it for one pool of robots, as we add new types of robots to our fleet, we can easily plug them into the existing facilities that we have. And we have different kinds of financing facilities, some of which we use to fund our more experimental stuff. And then once we have a good prediction of what the expected returns are going to be on those robots, we can plug them into. Because what you need is not just utilization information. You also need operational costs, right? Like how much is it going to cost me to keep that robot up and running? What's the depreciation curve going to look like? What is the expected spare parts need going to be, right? Like what are the software upgrades that I'm going to need over time? Like all of these things require a bit of underwriting work to be able to do. Yeah,
it's not as simple as saying, all right, we're going to charge $30,000 and we're going to make a 40% margin on it, and we can underwrite it to, whatever.
I think to your point, I think a lot of people misunderstand robot as a service to just be a different pricing model.
Yes.
It's like, either I can price it for $100,000 up front or $30,000 a year. And I think people who go down that route tend to really, really regret offering a robot as a service model. I've seen many, many startups actually who offered a robot as a service model for a few years and then basically ran out of cash and then went back to CapEx sales because if you don't build the infrastructure to fund it, you're not going to be able to scale that business up.
Are you still seeing from the customer side a disconnect between what the robotic companies want to sell versus what the customer wants to buy, right? To be able to make a large CapEx investment like that, you got to find a certain profile of customer. But we are seeing, just on my end, the labor shortages across manufacturing, across transport, across shipping. They're all hungry for robotics, but they don't necessarily have the capital profile to afford it. How do you bridge that gap?
But to add one layer of nuance to it, it's not that they don't have the capital, because they use their capital to buy forklifts all the time. Mm-hmm. They use their capital to build new buildings all the time. They have CapEx actually, right? Manufacturing businesses spend CapEx day in and day out. What they don't have the CapEx for is to put it against something that they perceive to be risky or uncertain, or out of their field of expertise.
Yeah.
And I think robotics falls squarely into that category, right? It's like, look, I run a chocolate chip cookie factory. I'm very good. I know everything there is to know about chocolate chip cookies. I know how to run forklifts. I know how to do kind of baking machines. I know how to get a new warehouse. That kind of stuff is in my wheelhouse. I'm not also likely to be an expert in robotics. And so when you show me this kind of newfangled robot thing, my first impression is going to be, that's cool. I know I want it, but how do I know it's going to work? Mm-hmm. How do I know I can keep it running? And one of our sales pitches is, we say, kind of avoid the Tarp of Shame. So the Tarp of Shame, if you're not familiar, is this term we invented, which is it's very common in factories to spend a bunch of money on some piece of equipment that they think is awesome.
Yep.
And then it works for a week, and then it sucks, and then slowly it kind of gets pushed into the corner of the factory, and then they cover it, and they said, let's not ever...
With a tarp, yeah.
Yeah, and let's never talk about that again. And so this is, unfortunately, a very common occurrence, right? If you talk to any factory owner about the Tarp of Shame, they'll immediately laugh, and they'll be like, oh yeah, we have 3 of those in the back, right? So really what it is about risk mitigation. right? Or it's a risk arbitrage, or like who should own which part of the risk. So going back to what your earlier question is like robot as a service is a better proposition for the customer because it says, don't worry about how much it costs. Don't worry about keeping it running. Only pay for performance.
Mm-hmm.
I mean, like basically like
Great deal.
yeah. The main like directive I've given to my sales team and our product team is like invent a product that you would have to be stupid to say no to. And I think we've gotten pretty close to that. Like literally sometimes our salespeople go in, I've heard this pitch where they go to the CFO of one of our customers and they say, you are going to be financially irresponsible if you don't buy this thing, right? Because just look at the numbers. Here's the spreadsheet. Like what reason could you possibly have to say no? And like that's the goal, right? I think that's the goal of every startup is to like get to a point on your product definition that they feel financially irresponsible.
Well, you do some aggressive things too. You offer a 3-month trial, no fault money back guarantee. Has anybody ever sent a robot back, or anybody ever said, this is not exactly what I thought it was going to be, and what has that taught you?
We have had some customers send them back, of course, for a variety of reasons. Usually it's because just like utilization is not high enough to justify it. But we also have, like, obviously in that situation, we have to do a lot of work to vet that this is a worthwhile opportunity for us to pursue, right? We choose to drop out of deals all the time, right? To the anger of our sales team very often, right? But of course they want us to say yes to every possible project. But what we do is we say, look, we know what the range of capabilities are that we feel comfortable to support, and if it fits into this range of capabilities, then we'll sell you something.
Yeah.
We're not going to try to overpromise and underdeliver, right? Because that ultimately leads to a bad ongoing relationship. So the result of that is we have now a 97% renewal rate. So
awesome.
Basically zero, like as close to zero churn as you can get in a startup. And we have a ton of expansion in customers. I think our net dollar retention is like 180% now. So every customer starts with a couple of robots, they see that it works, and then they expand and get a bunch more over time. And so that consistency is really like the seed of that is planted before you ever deploy a robot, right? It has to be, you gathered all the information about the customer, about the width of the doors, the size of the boxes or the items that you're picking, all these different things. And then you qualify that opportunity to such a point that you know that when you deploy it, you're going to be successful.
Yeah. You have 3 kind of customer profiles that I came across. So one is the 3rd generation family business where the factory is the family's legacy and everybody's really bought in. The second is the PE-owned portfolio company. A lot of those going around today, especially as private equity becomes a bigger part of manufacturing and these dirty jobs. And then the last bit is the first-time manufacturer. We'll call it the American reindustrialized story. Somebody who gets a head full of steam and says, hey, I'm going to go make widgets somewhere out in Wyoming. And these are 3 very different customers, but all of them are facing similar flavors of the same challenge. What have you learned about selling into these 3 different profiles that would help a robotics founder that's listening today?
All of them are concerned with one primary objective, which is how can I be more competitive in my business and win more business? What I'll say is for the legacy manufacturing businesses in America today, the vast majority of them are actually turning down business every day. Like they have opportunities to do more, but either can't meet the price point or can't meet the throughput to hit it. This is where robots play a really big role. So maybe actually just like before going into the specific customer profiles, like one piece of context that's really helpful for people who don't spend a lot of time in manufacturing is to realize how big the labor gap is today. So there are currently about 1.2 million unfilled manufacturing jobs in America right now, and expanding very, very quickly. And also just to put another like data point, I went and visited one of our customers a few weeks ago in New Jersey, which is a relatively highly dense labor available state. And they had, the factory is about 160 employees altogether. In calendar year 2025, they had to hire 275 people.
The turnover was that high?
Just to keep that factory running.
Wow.
And so, like, there's not at all a narrative here around, like, robots taking jobs or anything like that. it is purely a factor of these factories are struggling to even keep themselves open to meet basic production. Again, like the typical factory in America runs for about 1/3 of the available production hours in a year. So with that context, right, I think each of these three segments that you described are facing the same set of challenges. They can't win more business, they can't hire more people, and they're struggling to meet the demand that they're already encountering. So that's certainly like a good situation because there's a lot of pull, right? There's a lot of interest in robotics. I will say like the way they make decisions though is very different. So the family-owned businesses are generally very concerned with not screwing things up, right? Because and this is actually really interesting because it's different from my experience in China. So when I lived in China, I worked with a lot of factories, and many factories in China are still founder-owned and operated.
Yep.
Right. And so when a factory is founder-owned and operated, like they're willing to take a lot of different kinds of risks, and it's not uncommon for you to go to a factory in China and you can see that in one room they're producing aircraft parts. In the other room, they're making dog biscuits, and in the basement, they're making dolls or something, right? Like,
hopefully they never mix it up.
You never know.
You're at Boeing and you get a
go
box
there and
of
you're
dog
like,
biscuits.
how are you doing all of this stuff? Why are you doing all these things? And they're like, I saw an opportunity and I jumped into it, right? And so for people like that, the enthusiasm and the willingness and the ability to try new technology is extremely high.
Yeah.
In American manufacturing, that's not typically the case. Right? Usually it's third or fourth or fifth generation owned businesses. And there is a lot of focus around maintaining what already exists. And maybe there's many family members involved and whatever, decision making is hard, etc. And so a lot of the time these businesses are like the backbone of their community, but they're very concerned with, if I overextend myself, I can go out of business. And it's true, like it happens all the time. So I think risk mitigation is critical for those kinds of businesses.
Yeah.
For private equity owned businesses, it's a little bit different. Private equity owned businesses, generally, it's a much shorter time horizon. They're thinking about, like, how do I flip this business in the next 5 years? And so generally, it's about how do I reduce OPEX quickly and increase revenue quickly without taking on any new CapEx.
Yeah.
Because usually these businesses are levered so heavily that there's no more lending available anyway. And so in that type of a world, I think, private equity owned businesses are looking for basically like the quick fix.
Yep.
There are exceptions to that. We do have a lot of customers that are private equity owned and are very forward looking and thinking ahead. But there's generally among private equity firms a short term focus. And then the third category is like new plants that are just spinning up.
Yep.
And for them, it's about utilizing technology, utilizing robotics to quickly win business.
Right. Compete against the incumbents.
Yeah, exactly. Yeah. How do you build a self-sustaining company really quickly? And again, I think in all three of those situations, like robots are unanimously like the best answer to all those questions. But how you actually deliver and how you actually sell to them looks a little bit different.
When you stack rank them inside of your business, I'm sure you sell to all three. Who makes up the majority of the folks that either come to you or are the most receptive when your sales team reaches out?
Kind of family-owned businesses are probably the biggest segment. Family-owned could mean like actual family. It could also just mean like a consortium of like private investors who kind of came in and bought a company and want to run it. There are a lot of companies like that in the U.S. right now. One interesting stat, which maybe a lot of people don't know, is 98% of American manufacturing businesses are SMBs, the small medium size. 98% is a very high number, but if you think about it a little bit, it makes sense. Which is if you look at like a single like General Motors factory or a Tesla factory, there are about 5,000 suppliers that build various components that they ship to Tesla or General Motors to assemble into a car. Yeah. So typically these end plants are just the final kind of assembly. Maybe they make the engine block, maybe they make a couple of critical components. But that 5,000 to 1 ratio is very common in automotive. In aerospace, it's more like 25,000 to 1 or 20,000 to 1 or something like that. In In CPG, it's like a few hundred to one.
Yeah.
But generally, for every big company, you have a few hundred or a few thousand small companies that make the different things that show up
Yeah.
there. So, both from a labor headcount perspective, from a total spend perspective, from a production jobs perspective, the majority of the market is in this fat long tail
Yeah.
of the business.
You talked about the narrative around robots taking jobs. I'd love to sit with that for a second. Turnover in factories is 200%, year on year. We've seen it even higher in one of our companies in recycling, where the turnover in a recycling plant is like 500% year on year.
Yeah, for
These are
sure.
just dirty, dusty, dangerous jobs.
Yeah.
So when you go into one of these facilities within manufacturing, just in your context, what's that conversation like? How are the human beings that are still there thinking about their new robotic coworkers? What's that, change management conversation like? Or is it something that folks are very, very accepting of?
I'll say people are very excited
Really?
when robots show up. Well, like we also play some games around. Like we do a robot naming party when the robot shows up, and we bring a birthday cake for the robot, and all the staff get to name it, and we stick the name on the robot. So there's a lot of like fun things that you can do to kind of get engagement. But generally, these robots are doing the most painful, most backbreaking, most laborious tasks in the factory. And what you may not realize about these factory jobs is that those types of really backbreaking, repetitive jobs, typically there's not a person who sits there all day and does that. Like you can't pick up 50-pound boxes for 12 hours a day. So what they do is they rotate in and out, right? They'll spend a couple of hours doing nice, fun jobs, and then they'll come back and do 2 hours of this, and then they'll go do something else, and they'll come back and they'll do another 2 hours. So everybody wants to skip that shitty part of the work if they can. So when the robot comes in, everybody celebrates, right? Because they're like, I know I don't have to do this really horrible part of the job anymore. I can do all the other stuff that is much more enjoyable. So I'll say, yeah, like the only people that we've really heard this question of like robots taking jobs from is mostly reporters that we've talked to. Like anybody in manufacturing just knows very clearly that that's not the case.
Yeah, it's more of a media narrative than an actual buyer concern.
Yeah.
Yeah. Well, speaking of media narratives, right, you touched at the beginning of our conversation about how much money in the last, let's even call it 3 years, has gone to humanoids. You wrote in Forbes, I think, some while back, that the market is really missing it, that the humanoid hype is purely hype. So make the case, what is this humanoid obsession really about? And why do you think it's a distraction?
I think the fundamental issue with humanoids is that it just lacks creativity. If you were redesigning something from scratch, why would you keep it to 2 arms and not 6 arms, right? Why have 2 legs and that can walk 2 miles an hour instead of wheels that can go 60 miles an hour, right? Like there's you're making a lot of trade-offs in order to make it look like a human. And I think, this is like, I'm stealing a line from Steve Jobs, right? But like a human is one of the slowest animals on planet Earth, but a human on a bicycle is one of the fastest, right? And I think that we have this ability to drastically improve the form factor, and like I don't understand why we would choose not to.
Well, to push back, we're designing around a world we live in, right? Our homes have stairs, our factories have narrow doors. A 6-armed wheeled spider bot is not going to be able to fit in through the door, but a slender humanoid will. So in some ways, yes, if you could design the entire world from scratch, you wouldn't design it for a human. But we're in this weird transitional phase where they have to fit into a factory from 1950. I mean, that takes feet,
Sure.
doesn't it?
Not necessarily, right? But I think it is a good point. Like there are definitely a set of tasks that only the human form factor will either fit in or be able to do. Totally granted, right? And so I don't think that the humanoid demand is zero. There's definitely going to be a need for human form factor. My main contention is that you lose a lot in that choice. And so in a factory environment, for example, or in a farm or in a construction site, you would say, do I want superhuman capability for a slightly different form factor, or do I want human or subhuman capability for a human-like form factor? And sometimes you'll choose one and sometimes you'll choose the other. That's totally fine, right? And I think that there will be some people who in some situations will need to choose less than human performance and less than human capability in exchange for being able to fit in. To your point, maybe a factory doesn't have space. That's the only thing that will work. But the vast majority of environments, from what I've seen, are places where you want like far superior than human capabilities. So, like, I mean, and the reality is like we've made this trade-off many times in human history in the past, right? So look at, for example, a lawnmower, right? Like you don't make that in a human form factor and say, go down with scissors and cut every grass. Like you design something that is appropriate for that job. I think the real question is, to what extent are you going to need these robots to perform multiple jobs?
Yeah.
So in most like B2B use cases, like factories, construction sites, farms, hospitals, a robot is going to be doing one or a few things all day, every day. You don't have the same robot that is like packing boxes, also washing your windows. Like you just pick one thing and then you just make it really, really good at that thing. And so I think that's the trade-off is picking the tasks that are appropriate and then getting the form factor that makes sense for that task. And then when you do need some generalizability, right? Like you will have some gap filler robots. I think in those cases, a humanoid makes sense where you can go in between existing tasks and do basic.
Well, that was the crazy thing to me is this maybe 4 or 5 months ago when Figure put out a video of the robots moving packages in a like UPS facility, right? And not to pick on Figure, I'm just using it as an example because they have a very public video presence, much like Boston Dynamics did, a decade ago. I looked at that and I go, that seems like a great point solution. All it's doing is picking up the package and moving it. The humanoid story to me makes a lot of sense when you are in a highly variable environment. Every home looks different. Every toddler's toy is slightly different. The robot needs to have the generalized ability to navigate that. But the people who are willing to pay for it, because no person or few people are going to pay $250,000 to put a humanoid in their home. And oh, by the way, it could fall on my dog. Like that's scary
Very
stuff,
dangerous,
right?
Yeah.
But at the same time, the story and the narrative on these things is they'll be in your home one day, but where we're deploying them today is actually somewhere that a point solution makes sense.
Yeah.
Am I wrong about that dissonance?
No, I think we're in complete agreement. But I will say, like, I'm not pessimistic about it because there's this. I don't know if there's this guy Chris Anderson who used to run Wired, and he wrote this piece a while ago where he talks about this idea of like the peacetime dividends of the smartphone wars. And so there was like all of this massive investment that went into smartphones that trained a supply chain that drastically reduced the cost of compute, of cameras, of sensors,
miniaturizing,
and built a bunch of software around it. Right? And then those exact same components and supply chain were the foundation for, at the time he was running a drone company. Right? So he said, okay, now we can make drones using these cheap cameras, cheap compute, low cost, small size. And I think the exact same set of capabilities is coming to robotics, right? So we benefited as a robotics industry a lot from the miniaturization of smartphones and smaller and cheaper compute. But also I think there's going to be the peacetime dividends of the humanoid wars and the peacetime dividends of the self-driving car wars, right? Where people invested massive amounts of capital into self-driving car companies, which trained a generation of edge compute, low-cost cameras, low-cost LiDAR, algorithms and things like that. All of those are very foundational for like what's happening in robotics today. Same thing goes for drone companies. Are now a lot of what's feeding robotics. A lot of the like Unitree founding team used to be ex-DJI folks, right? So like you see this pattern again and again where some amount of overinvestment in one category benefits whoever comes next.
Yeah, great for whoever comes next. Not so great for the investors that are in some of those businesses.
Yeah, you try to warn them. I don't know.
It's falling on deaf ears. I'll put it that way. You brought up drones, so we'll talk national security for maybe a bit. Robotics and drones have entered the national security conversation. You gave testimony in Washington, D.C. on this topic, and you've spent time in China, so you're seeing what's happening over there and how they're thinking about chips, drones, robotics as a national security priority in China. Let's say I make you the robotics czar for the U.S. What needs to happen over the next 24 months for the U.S. to succeed or take the top spot in robotics from a national security standpoint?
Advocate very strongly for good users of robots become good makers of robots. I think the first thing that we need to do in America is use a lot more robots. I would heavily incentivize the utilization of robots, and I think that will in turn train the supply chain. Some of those will be from China, right? I think China makes very good components, very good hardware, but the one of the key reasons why they're able to is because they've trained their entire supply chain on providing other kinds of industrial machinery at scale and utilizing robots at scale. And I think in America right now, what many people may not know is 90% of factories don't use any robots at all. And let alone if you go out of manufacturing into other industries, adoption is even worse.
Yeah.
So I think building the robotics capability of the United States comes from being a very good user of robots. I'll say kind of the secondary thing is that there's a lot of enthusiasm in investing in the final robot manufacturing capabilities, right? They're saying, oh, America needs to be good at making robots. The reality is if you look at China's industrial policy, it's taken kind of a layer by layer approach, right? So they started in the 70s and 80s with like incentivizing basic like materials manufacturing. How do you make steel? How do you make forges? How do you make basic nuts and bolts and screws and very like low cost components? Then they moved up the chain a little bit into making toys and simple assemblies and basic machinery. Then they moved up to like more complex machinery and more complex, smartphones manufacturing, all of these types of things. And only from there can you then go to manufacturing like very advanced equipment and shipbuilding and drones and robots and solar panels and semiconductors. Like these things are a pyramid, and you start from the bottom and you work your way up. And I think the U.S. used to have this pyramid, but a lot of the bottom pieces over time have kind of gone away, right? And so now what's happening is everybody's investing heavily at the top of the pyramid.
Yeah.
They're saying we want more chip factories, we want more robot factories, we want more. But like, how are you going to make a robot if you can't make nuts and bolts?
Where are the actuators?
Yeah. How are you going to make the motors? Where are the magnets going to come from? And so I think that from a policy perspective, I really would encourage like focusing on the simple manufacturing tasks and then working your way up. So this is a long-term process.
Yeah.
I think, so I think this is maybe more of a general industrial policy question, but I mean, I think the exception to a lot of this is the defense industrial base.
Yes.
But what you see is like the reason that it costs 10 times more to make any kind of defense component in the U.S. than it does basically anywhere else in the world or in the commercial world is because that's the only segment that has to be made in America. And so you make a bunch of compromises in order for it to be able to be made in America, and you end up with a whole supply chain that's highly targeted to make this one special component, and they're often 10 or 100 or sometimes 1,000 times more expensive than like the commercial counterpart that you would get. So I think what a lot of investors are getting wrong, in my opinion, who are investing in manufacturing technologies, is that they're over-indexing on the defense base. The reality is the defense base does not train world-class suppliers. What it trains are, it's a constrained zoo where you have to buy, whatever is in that segment. Whereas in like kind of more commercial applications, companies that succeed have to be fit on a different level, right? Like you have to be competitive on a global stage. And so I think there's definitely money to be made in kind of investing in just pure defense technologies, but I don't think it trains the best suppliers.
Does some of this get fixed as we reshore more? I mean, one of the things that blew my mind as I was just looking at components for some of our robotics companies is how much round tripping happens. You go, okay, we built the small component here, we send it gets assembled in the U.S., it gets sent back out to Vietnam, then it ends up in Mexico, then it's on a pallet truck, through the Texas border, and then finally we get here, and it's gotten its visa stamped 3 times in and out of the U.S. before it actually gets in our hands, right?
Yeah.
As you start to reshore some of that, does this problem naturally go away, or does it require kind of a more holistic look? Am I oversimplifying it?
No, I think you're asking the right question. And if people were actually reshoring all that stuff, then yes, right? Like that problem would solve itself. The problem is what I've seen in most of these conversations in DC and otherwise is that the conversation tends to focus around the top of the pyramid. How do we make chips in America? How do we make drones in America? How do we make blah, blah, blah in America? People aren't thinking about how do I make nuts and bolts or, rubber seals or very basic components. Like magnets somehow have captured some attention, but
Yeah.
like there's generally a lack of interest on the boring stuff, the foundational boring stuff. And like, so as a consequence, like I don't think those things are really getting reshored to a large degree.
Yeah. If we look 5 years out, maybe this is a good place for us to close. If we look 5 years out, Formic's leading the charge, but more factories, more manufacturing facilities have brought robotics in as a core competency, as a part of, their human coworkers and the robot coworkers. What does that future look like? And then I guess paint the alternative of what it looks like if, we're still at 90% plus of these facilities not using robotics or unable to access it.
Yeah, I mean, I think the core of your question is what motivates us every day to do what we do, which is we want to live in a world of abundance. And I think abundance means abundance in kind of every aspect of at least in our material lives, which is what we have control over from a robotics perspective, is not just the demands of the United States, right? But there are billions of people on planet Earth that don't have enough of the basic necessities of life. And in my mind, a lot of that actually comes down to just supply chain efficiency, right? It's like the boring answer. It's not the thing that's going to win the Nobel Peace Prize or anything, but like you just have to improve your supply chains. Like you need to produce much, much more for less, like faster and more efficiently. So I think if we do our jobs well, if we succeed as a robotics industry and as a robotics company, we can train a generation of manufacturers that are 10 times or 100 times more productive than they are today. And I think that ultimately leads to a world where like the basic necessities are easily available to everybody. I don't see this as a competition necessarily between U.S. and China. I think the world needs both of these countries to be strong and have a strong industrial base and have a strong supply chain, and many more countries beyond just these two. But I do think that it should be a wake-up call for Americans and American manufacturing when we look and see that we've kind of been resting on our laurels as a manufacturing industry for the last 20, 30 years.
But you do sound, forgive me for putting words in your mouth, you do sound on the whole optimistic that America is moving towards reshoring and reindustrializing that bottom of the pyramid.
Absolutely.
I hear you're bullish on China. I guess what are you seeing that's making you bullish on America catching up?
No, I mean, I think to put it plainly, we see it every day, right? We work with manufacturers who are desperate to modernize and are trying very hard to. All I'm saying is I think from a policy perspective, there's a mismatch between where the energy and attention is and where the actual change is happening.
Yep.
But you're 100% right. At the grassroots, these factories are, like the factories that we work with, they're brilliant, they're hardworking, and they're enthusiastically trying to adopt new technology. It's our job just to make it easy for them to do so. And to give them the support, right? I think that manufacturing is just a heavily overlooked and like unsexy industry, and like young people don't want to go into it. A lot of these family businesses, they have a new generation that doesn't want anything to do with the manufacturing business, and so I think that it's important for America to kind of remember where we get all of our stuff from. Like basically, if you look around this room, every single thing here was made in a factory, right? This couch, these fake plants, like
calling out my fake plants.
Right, like every single thing that you see and you touch, like this thing that I'm wearing, my shirt, my food that I bought in my, from Whole Foods yesterday, every single thing is made in a factory, right? And so like the extent to which we're reliant on the manufacturing industry and don't think about it, for me is very shocking.
Yeah.
No, anyway, my favorite activity recently is just like I take my son to Costco and I get to point out all the stuff that our robots help make, and I was like, it's really fun.
That's awesome. Well, and I appreciate the call to America's competitiveness to say, look, it doesn't have to be a two-country race. I know there's political reasons why people are pushing that narrative, but more importantly, there is a abundance that comes from having the confidence in your supply chains, not having to worry about ships waiting off the, port of Long Beach for you to be able to get your toilet paper. there's all these reasons why I think the last 5 years the conversation around reshoring and reindustrialization has come to the forefront, and I'm just excited that Formic and other robotics companies are meeting that call to arms. So
Yeah, I mean, I think it's worth noting, right? America is still the second biggest manufacturer in the world, right? So like, there's 250,000 factories in America. Like, there's a real base of infrastructure here, and I think that there's a lot of work to do to improve it and modernize it.
that's a great place to leave it. Saman, thank you so much for joining me on the show today.
Thanks for having me. This was a lot of fun. I appreciate it.
This is great.